This section is on hypothesis testing with two proportions from independent samples. And the steps are very similar to the previous sections. Now, the formula is kind of complicated. However, it's not too bad if we take it step by step. And we'll be using the p-value method on question 1. In a certain region, a study of 150 randomly selected occupants in SUVs shows that 129 passengers wear seatbelts. A study of 200 randomly selected occupants in sedans shows that 148 passengers wear seatbelts. At alpha equal to 0.10, can you reject the claim that the proportion of occupants who wear seatbelts is the same for SUVs and sedans in this region? Use the p-value method and show all work. So the claim is that P1 is equal to P2. And this is the null hypothesis. So the alternative hypothesis is P1 is not equal to P2, which means this is a two-tailed test. Alpha is 0.10, x1 is 129, n1 is 150, so p hat 1 is 129 divided by 150, which is 0.86. x2 is 148, n2 is 200, so p hat 2 is 148 over 200, which is 0.74. So if we plug these values into the complicated formula, we get this. So if we simplify the numerator, we get 0.12. Then I want to simplify the three parentheses in the denominator. So the first parentheses is 277 over 350. The second is 73 over 350. And the third is 7 over 600. So I can type that into the calculator, and it looks like this. And it's equal to 2.73. So that's equal to 2.73. And our picture looks like this. So to calculate the p-value, we have to take 2 times the normal CDF of negative 9,999 up to negative 2.73. So this is 0.0063. And because the p-value is less than alpha, we reject the null hypothesis. And the conclusion would be, at the 0.10 level of significance, there is enough evidence to reject the claim that the proportion of occupants who wear seatbelts is the same.